7th grade. Mr. Hahn coming to you here live. Well, not from very far away from you, are about 60 feet. We're going to review your pretest. I think this time I'm going to get it right. If you have any questions on that review, you can either talk to me, shoot me an email or whatever, but I hope to explain it well in the pretest, and we will have a chance on Thursday for you to ask a couple questions before the test. But again, remember, you can take out a piece of note paper and write yourself some notes for the test on things which you need to remember. Take that into your own hands. Give yourself a fighting chance. I'm going to share my screen here, and then we will get right down to it if things go well here. Boom. So here we are. Everybody's favorite. Look at this. I got it right. Math course 3-7A. That is you guys. So here we go. Right from the very beginning. This is where you'll get your answers. Hopefully you can follow along. Let's just take care of some business here. Number 1 says, at 6 a.m. the temperature was -4 degrees Fahrenheit. By noon the temperature had increased 12 degrees. What was the temperature at noon? As always, ladies and gentlemen, please sketch these sort of things out because it really just kind of helps you to visualize this thing. So here's my thermometer. At 6 a.m. it was 4 degrees below 0. So here is 0. Here, let's pretend this is -4 degrees right here. Then it went up 12 degrees. So basically you took 4 degrees to get to 0. So if you took 4 of the 12 degrees to get to 0, how many degrees are left? Boom, you would only have 8 degrees left. So your answer should be 8 degrees. Now really what this is, without doing the thermometer, is a integer problem, -4. You're adding 12 to it. And remember the rule, when you add integers, if they have opposite signs, you actually subtract them and take the sign of the bigger number. So when I subtract 12 from 4, I get 8. It's positive because there's more positives than negatives. But if you draw the picture, it seems to me like it makes a little more sense and it can kind of get you there. Number 2 says it's a ratio, and I very, very, very strongly encourage you to draw yourself a ratio box. The length of the field to the width. So here we go. Before I even look at the numbers here, I'm going to draw myself a ratio box. Okay, this is the ratio. This is actual. What am I comparing? The length to the width. Length given first. First number, the length is 3. The width is 2. If the field is 120 inches long, that's the length. Length and long, and width is wide. So the 120 goes here. The actual is 120. And you just need to figure out what this is. Well, it's a pretty simple little procedure here. You have to say, okay, what times 3 gives me 120? Well, hopefully you can see 3 times 4 is 12, and then you're missing a 0. So it's 3 times 40. So 2 times 40 would be 80. Answer to number 2 is 80 yards. Boy, we are making some serious progress here. Number 3, the table shows the results of a 100-meter race. The first place finisher ran how much faster than the second place finisher? Anytime you're asked to compare, ladies and gentlemen, how much faster, that means you want to know the difference. And when we do difference, we subtract the smaller one from the bigger one. The first place finisher finished how much faster than the second place finisher? So you need to do 14.02 and subtract 13 point, is that a 9? I just covered up my problem here. Let me look and see. Yep, it's a 9. 13.89. When you add and subtract decimals, remember you line them up. We need to borrow all the way from the 4. It becomes a 3. This becomes a 10, which you have to borrow from becomes a 9. So here's my 12. I get a 3 here. 8 from 9 is 1 with my decimal point, and that's it. So it's just 0.13 seconds faster, or 13 hundredths of a second faster. Number 4, oh, this one is going to be an exciting one. I can tell already with all the decimal points there. At $2, 2.249 cents per gallon for regular gas. What is the cost to the nearest cent of 9.1 gallons? Now, remember, that isn't asking you to round first. You have to do all of the math, and then at the end, children, you have to change that to the nearest cent. So don't change this to $2 and that to 10 gallons. Nope, nope, nope. This one you just have to do a little bit of work with. So here we go. I'm gonna do 2.249 times 9.1. And you'd be thankful that at least they gave you a nice little 1 here to deal with. So 1 times all of those numbers is 9,422,2249. Now, when I get to the second digit, I have to put the 0 down. Let's multiply by 9. 9 times 9 is 81. Carry the 8. 9 times 4 is 36. Plus 8 is 44. Carry the 4. 9 times 2 is 18. Plus 4 is 22. Carry the 2. 18 plus 2 is 20. And let's see when all the fun begins here. 9, 5, 6, 4, 0, 2. Look at all those digits. Somehow we have to get some money out of that. Well, let's see, where does our decimal go? There are 3 decimal places there and 1 decimal place there for a grand total of 4. I come back 4 places. 1, 2, 3, 4. So my answer, ladies and gentlemen, is 20.4659, almost. This said round to the nearest cent, and the cent is in the hundreds place. This is the number I'm rounding right here. My answer is either going to be $20.46 or $20.47. What tells me which one that is? Well, it's the number next to the cent that tells you that. This one tells you that. 5, if this is 5 or greater, that's more than 1/2 of a cent. So you'd have to add 1 to that. So this ends up being 20.47 or $20.47. Now don't just assume that every time it's going to be rounded up, because if this had been a 4, this would have stayed a 6. So write some notes to yourself. $20.47. Let's keep this thing going. Number for 5 and 6, I am using this spinner. By the way, it's always good to look at the directions before you do something. If the spinner is spun twice, what is the sample space? Now remember, sample space is the possible outcomes, and you're spinning this twice, and it's a set of numbers. And in math, when we show sets, we show that by putting this little brace thing here. So what are my sample spaces? What could I get? Well, I could spin an A first and then A second. I could spin an A first and then a B. I could spin an A first and then a C. That's all that happens when I spin an A first. But then I could spin a B first and then spin an A. I could spin a B first and get a B. I could spin a B first and get a C. Those are all the things that can happen when I spin B's first, and then I have to spin C's. I can spin C first and get an A, C first and get a B, C first and then get a C. These are all of my possibilities. I have no other possibilities there. There are 9 of them, and that's the answer to number 5. If you spin the spinner twice, what's the probability it will stop in the sector A at least once? Well, you need your answer to number 5 to answer that. You know that when I spun it twice, which is what I did up here, I had 9 possibilities. And I am looking for the ones where there's at least one A. So if I go up there and I look for the ones that have at least one A, well, this has at least 1, it has 2, but that's fine. At least one A, at least one A, at least an A, and at least an A. How many of them were there? There were 5. So 5 of the 9 spins had at least one A. And there is your answer for number 6. Number 7, a door handle turns the position from A to position B. This is an example of, well, if you go to your notes under translations, or transformations, I'm sorry. A translation means it just moves without changing orientation from one place to another. A reflection means that it flips on itself. A rotation is a spin, and a dilation means it gets bigger. Well, this one, obviously, it moved from here to here, so it spun just a little bit. So the letter B is my answer. Problem number 8. The mean distance of Venus from the sun is about 1.08 times 10 to the 8th kilometers. What is that number in standard form? All right, let's go back and talk about scientific notation, children. What you have is this, 1.08 times 10 to the 8th. This exponent tells you how many places you move the decimal. So I'm going to take the decimal starting right there and move it 8 places to the right. So it's going to go 1, 2, and then I'm going to have 6 more, 3, 4, 5, 6, 7, 8, which means I'm going to add zeros for all 6 of those things. It was 8, but 2 of them were taken up with the 0 and the 8, so 1, 0, 8 with 6 zeros. And please do us all a favor and stick some commas in there so it's easy for Mr. Hahn to grade, look at, and read. So in standard form, that is 108 million. 108 million. Here we go, ladies and gentlemen. Making quick progress here, changing colors to a shade of blue here. For questions 9 and 10, refer to this rectangle. Question 9 just asks you for the perimeter, which means add all the sides. So if I'm going to perimeter equals add all sides, you might want to jot that in your notes. I am just going to take 2 and 1/4 plus another 2 and 1/4 plus 1 and 1/2 plus 1 and 1/2. You can do this multiple ways. I don't know, I guess we might as well change all our denominators to 4s. This one already has 4. This one already is a 4. 1/2 equals how many fourths? Well, I multiply both top and bottom by 2. A half is 2/4, and this half is also 2/4. Looks like I'm running out of space here, but let's do it in a different color so we can see it. So here I have 1, 2, 3, 4, 5, 6 fourths. And here I have 2, 4, 5, 6. 6 and 6 fourths, which, as everybody knows, is just needs to be fixed up a little bit. 6 fourths, cut them both in half to reduce, you get 3/2. And 3/2 is an improper fraction, which is as a mixed number 1 and 1/2. So I take that 1 and I add it to the 6, and my answer for this is 7 and 1/2 inches. 7 and 1/2 inches. Area of a rectangle is length times width. Good thing to have in your notes. And here you go. This is multiplying 2 fractions together, actually 2 improper fractions. Area equals 2 and 1/4 times 1 and 1/2. Making them improper, remember, to make them proper, you multiply the whole number times the bottom, add the top. 2 times 4 is 8, plus 1 is, sorry, do that at least a couple times every time. I get 9/4 for this, and I get 3/2 for 1 1/2. And then when you multiply, sorry, this should have been multiply, you multiply across. 9 times 3 is 27. 4 times 2 is 8. Again, I cannot leave it as 27/8. I have to change that to a mixed number. I divide 8 into 27. If you have to do it out as a problem, by all means do it. 8 goes 3 whole times into 27, which is 24. My remainder, I make that fraction out of, take 3 and put it over 8. So the area of that rectangle is 3 3/8 inches squared. And everybody's happy. Write 1/6 as a decimal and a percent. Please make sure this should be very, very, very easy for you, simply because I put it on your reference sheet. And you can have that reference sheet for math. You can have that out. If you don't have the reference sheet and you want to do it the hard way, the simplest way, the basic way to do this is this. You just take the bottom and divide it into the top to get your decimal. How many times does 6 go into 1? Well, It goes 1 here. I subtract, I get 40. I get 6, which is 36. And I'm going to keep getting 40s because it just keeps repeating. So there is my repeating decimal. That's my decimal. My fraction, if I'm doing this as a fraction, I have to move the decimal from changing that to a percent, I move the decimal 2 place. It's 16%. But here I do take my remainder and put it over my 6. I get 16 and 4 6%. But I have to reduce that fraction to make it 16 and 2/3%. But again, all that you should not have to worry about if you just take your reference sheet out and look at it. That's one of those you have on your reference sheet. Problem number 12. I know people have issues with this, so let's take a look at it. We are taking 288 over 360, and it asks you to do 2 things: to prime factorize it and to reduce it. So prime factorization can be, well, it's up to you what you want to make of it. It's just one of those things you just have to do. I'm actually going to do 288 by division by primes, which means we do this. You start with your number, and you just keep trying to divide it by prime numbers. And if it's even, the smartest thing to do is just keep cutting it in half till you can't cut it in half anymore. If I cut 288 in half, I get 144. If I cut 144 in half, I get 72. If I cut 72 in half, I get 36. If I cut 36 in half, I get 18. If I cut 18 in half, I get 9. And 9, you can't cut in half, but you can divide it by the prime number 3. So 3 times 3 is 9. So here are all of my prime numbers that give me 288. And it looks like there are 5 2's and 2 3's. So I make a fraction out of that. 5 2's, 1, 2, 3, 4, 5, and 2 3's. That's my top number. 360, just for fun, I will make a factor tree out of. And when I do this, I just kind of like, I see a 0 at the end. I'm going to say, well, that is 36 times 10. Those both have to be broken down. 36 to me is, I don't know, 4 times 9. 10 is 2 times 5. I can stop with the 2 and the 5 because those are both prime. 4 gets broken down into 2 times 2. And 9 gets broken down into 3 times 3. All of those are prime, so I can stop. So as I see this, I end up with 1, 2, 3 2's, 1, 2, 3 2's, 2 3's, and a 5. A lot of work going into this problem here. Now once you get to this point, it's pretty simple because at this point you just cross off 1 for 1 like factors. So these 2's will cross off. This and this one will cross off. This and this one will cross off. These 2 2's don't have anybody to cross off with because I already crossed off all the 2's. This 3 will cross off with this 3 and a second 3 with the second 3. Nothing left to cross off. Once you've crossed everything off, then you need to re-multiply to get back to your whatever your factor is. So I have 2 2's up here, which gives me 4 and 1 5 on the bottom. So my answer, when that whole thing, all the smoke clears, you get 4/5. Problem number 13, triangles ABC and DAC are similar. That means this triangle here, ABC, is similar to DAC, the 2 back-to-back triangles. What side of DAC corresponds with side AB? Well, here is side AB. All right, corresponding means matches up, is equal to, or whatever here. And you just have to say this, well, side AB is the side opposite the right angle, or it's the longest side, either way you think about it. So the side that corresponds to that would be the longest side on this triangle. And what is the longest side? Right here, side AD. So boom, AD, put a little side over it, and everybody's happy. That was a quick one, ladies and gentlemen. Here we go. Problem number 14. For your learning pleasure, let's change colors to a lovely shade of green, I guess. Just solving this one by inspection. All right, this one here, you want to either just look at multiplication or division. Since I know this one, I'm going to go from 12 down to 4. What do I do with 12 to get to 4? I divide by 3, so I just need to take 21 and divide it by 3, and that is 7. Look how easy that was. That one inspection means you should be able to do that one just by looking at it. Everybody's happy. Okie dokie, let's take a look at problem number 15. If you look at your notes about adding and subtracting integers, what is the rules? Okay, the rules were this. Either they have the same sign or they have opposite signs. If they have the same signs, you add them together. These both have the same sign. So I'm going to add 6 and 12 and get 18. And the second part to this is if they have the same signs, you add them together and you keep whatever sign they have. So since these were both negatives and I add them together, it stays negative 18. Remember, these are rules on adding and subtracting integers, not multiplying or dividing. What's the rule for subtracting integers? Subtracting integers is the same as adding, except before you add, you must do what? You have to take the second integer. Remember, you change the subtraction. Basically, you add the opposite is what the rule is. In other words, this, instead of subtracting a negative 9, I add the opposite of negative 9, which is positive 9. Instead of subtracting, you add the opposite. And now I go back to my rules of adding integers. Okay, since these have opposite signs, the rule is if they're opposite signs, when you add, you subtract them. And if I take 9 and subtract 6, I get 3. And you take the sign of the bigger number. Which one is the bigger number? 9. So I keep that sign of positive 3. Got that? It may do you well for problems 15 and 16 to write those rules of integers down. I mean, this could be kind of confusing, kind of, but not super confusing. Problem number 17. Adding and subtracting fractions. Remember, an order of operations, adding and subtracting fall on the same level. So you do it from left to right. So I must do this first. I have to take 7/8. And I have to subtract a half from it. The common denominator is 8. What do I do to 2 to get 8? I have to multiply by 4. So I multiply 1 by 4. So 4/8 from 7/8 is 3/8. But now I have to add the 2/3 to that. Here's where things get kind of dicey. What is your common denominator of 8 and 3 but 24? 8 times 3. 3 times 3 is 9. 3 times 8. 2 times 8 is 16. Adding 9 and 16, I get 25 over 24, which again, you can't keep. It's improper, but 24 goes into 25 once with 1 left over. By the way, I'm hoping I'm getting these answers right. I'm not looking at the answers. I'm just doing this. There's a good chance it's not that I did something wrong. Right now, everything seems to be pretty smooth. I've had my coffee, so maybe whatever there. All right, problem number 18, 19, and 20. Let's get them done with. 18, you just have to be careful with because they do a whole bunch of stuff with decimals. You got subtracting decimals. You got multiplying decimals. Well, let's do this first. But remember, when you do problem 18, in your notes, I would write a note to myself that says you have to do this, get this down to one number, get the bottom down to one number, and then you can divide the bottom into the top. So the first thing I'm going to do is take 4.6, that was a terrible 4.6, and subtract 1.27. Remember, you have to line up your decimals when you do adding and subtracting decimals. 6 becomes a 5, I get 10. 3, 3, 1 from 4 is 3. On top, look at that, 3s are wild. On top of the fraction, I get 3.33. And I love the book because they always try to mess you up here. Everybody goes, I think I can do this in my head. And the answer is 0.9 when I multiply 0.3 times 0.3. But it is not. If you take 0.3 times 0.3, yes, you get 9. But there are 2 decimal places there, ladies and gentlemen. That means you get 0.09. Please watch out for that on your test. You have to stay focused on all of this here. And now I'm dividing decimals. So I have to take my top one. I take my 3.33 and I'm dividing it by 0.09. What's the rule when you divide decimals? The rule is over, over, up. If you're dividing a decimal into a decimal. So this goes over 2 places, so that's up there. This goes over 2 places here, and then it goes up from there. Now, the beautiful thing is knowing your rules of divisibility, you know that 9 actually goes evenly into 333 because of the sum of the digits. 3 plus 3 plus 3 is 9, so you know 9 actually goes into that. Let's see what it is. 9 goes into 33, what? 3 times is 27. I subtract, I get 63. 9 goes into 63 7 times. So when all the smoke clears, ladies and gentlemen, the answer to that should be 37. 37. And then on the last, well, on problem number 19, here we go. Let's do order of operations. Please don't eat, my dear Aunt Sally. Is that what it is? Please excuse. Yeah, you probably don't want to eat her. So remember, we do parentheses first. So the first thing we're going to do is this. 4 minus 2 is 2. And I'm just going to rewrite things because I always want to do things the right way. And then E is exponents and powers, and I do have a couple of those. 5 to the second power is 25. And the square root of 49, what number times itself gives you 49 is 7. Then I do multiplication and division from left to right. I only have one multiplication there, which is 3 times 2. So I get 25 minus 6 plus 7. Now, please be very careful at this point. This is where a lot of people go wrong. They go, oh, 6 plus 7 is 13 and 25. No, you can't do that. Addition and subtraction are on the same level. You must work from left to right. I must take 25 minus 6 first. And 25 minus 6 is 19. Then I add 7 to that. And I end up with 26 as an answer. So the answer to number 19 is 26. There might be a whole bunch of notes you want to write for yourself on that one, just because that's the way it goes. And we are in the home stretch, ladies and gentlemen. Problem number 20. Problem number 20. Here we go. Maybe it would help you for problem number 20 just to write this out in long form to see what crosses out. I'll do it 2 different ways and we'll see which one. I mean, whichever way, if it works better for you one way or another, pick the way and go. X to the third is 3 x's. X times X times X. That's this X to the third. To that, I have 5 more x's. So I'm going to add 5 more. 3, 4, 5. By the way, that's 8 x's on top if you're keeping count, but let's do this. On the bottom, I have 1 x and 2 more x's. So just like when we went over here on problem number 12 and prime factorize and I cross off top sums with bottom ones, I'm going to do the same thing over here. 1x crosses off with a 1x on bottom. A second x crosses off with a second x. And a third x with a third x. None of these have ones to cross off with. So if I have 5 x's times themselves, my answer is x to the 5th. And that is your answer. Another way, if you're mathematical and things come easy math to you, you know, x to the 3rd times x to the 5th. The rule is we add exponents, so I get x to the 8th on top. And x times x squared on the bottom is x to the 3rd. And the rule is, when you divide letters that have exponents, you subtract their exponents. So 3 from 8 is x to the 5th. But I would say for most of you at this point in your mathematical lives, this would probably be the way that you would want to do that one. So, 7th grade, I hope that was as exciting for you as it was for me. You know, maybe you might want to watch this video multiple times, you know, if you struggle, or just fast forward to the parts where you have trouble. Like I said, hopefully on Thursday, I will ask you if you have any other questions. I strongly suggest, you know, this is really the end of the grading period, this test. We have the week after, but not a lot of more chances for some more grades. So Thank you for tuning in, kids. Have yourself a great day.